Welcome to qnawire.
Problem 7.53. For some reason, we've tied a potato to the end of a string, and we've now fastened the other end of the string to it out horizontally with the string taut. And we drop it from rest, and we want to know at the bottom of the swing it goes through what its speed will be and what the tension in our string will be. So let's use conservation of energy. The string is, as a potato, and the string is initially at rest, so there's only going to be potential energy from gravity. No work is being done on the string by anything other than gravity. The tension in the string is always perpendicular to its direction of motion, so it can't do any work. And then this is going to be equal to, if we call this point the 0 point for gravitational energy, then its potential energy will be 0, and it will be all kinetic energy. So our masses cancel out. And our final speed is going to be 2 times the acceleration of gravity times the height, change in height that is dropped through. That's just going to be our 2.5 meters, because it's only the height that matters, not the x component of the displacement, because gravity is only pointing up and down and not either side. And so this works out to be 7 meters per second. So for part B now, let's draw a free body diagram. We have the tension in the string. We have the weight of the potato. Now, because this is moving in a circle, it has to have a centripetal force. So it be M AC. AC is V squared over R. And so the y acceleration has to end up being the centripetal. So we know that T minus the weight, this is the net force acting on it, has to be equal to the centripetal force. So mv v squared over r. So the tension has to be equal to the sum of the weight and the centripetal force that it's providing. And this will be 8.82 newtons. And an interesting thing to note is we can take this expression and put it in here, and we'll see what we get. So squaring this is going to get rid of the square root. Now h, the distance that it drops, is equal to the length of the string and also the radius of the circle through which the potato is moving. So let's call that big L. this is going to be 2G big L over L. This is the change in height, and this is the radius, plus G. This is equal to 3 mg. So the tension has to be 3 times the weight of the potato. So that's, and you can then put in the potato's weight directly into this to get that, instead of taking our 7 meters per second and sticking it in here. So this is kind of a neat way to do it. But either way gets you the same result.